Blender has a number of tools, many of which have an icon in the toolbar for easy access. You can view the names of these tools by dragging the border of the toolbar. You will only use a few of these tools to make Trainz models. The Extrude tool is one of the most useful tools in Blender. It is often the first tool you will use when you start your modeling, as it takes a 3D edge or face and extends it while keeping all the adjacent edges or faces connected. It has an icon in the toolbar, but I prefer to use the keyboard shortcut, the E key. The Extrude tool is used in edit mode. In face selection mode, selecting the E key will pop up a blue axis, upon which the face can be extruded by dragging. Specifying a distance will extrude the face along the axis in a precise number of units. In edge selection mode, an edge can be extruded in the same way, except that the blue guideline does not appear, allowing you to extrude the edge in any direction. Selecting the E key, then an axis, and entering in a distance will extrude the edge along the specified axis in the precise number of units. In vertex selection mode, a vertex can be extruded either in any direction or along a particular axis to a given distance, again by specifying the axis and the distance. With almost all modeling, you start with one of the primitives, usually the cube, and use the Extrude tool to build your model. But you can start with just a single vertex and extrude from it. To do this, you first need to use one of the symmetrical primitives, such as the cube, to create a single vertex. In edit mode and vertex selection mode, select the cube using the keyboard shortcut, the A key. Notice that it has a yellow dot at the center of its geometry. Since with the cube all the vertices are equidistant from the center, they can be collapsed onto its geometric center. Merge the vertices to the center of the geometry by selecting the Mesh menu, then Merge, then at Center. You can extrude the single vertex along an axis to form an edge. Then in edge selection mode, you can extrude the edge to form a face. The second most useful tool in Blender for making Trainz assets is the Loop Cut and Slide tool. The Loop Cut and Slide tool inserts a loop of edges on a mesh. Once added, the loop can be slid along the faces. Sliding can be manual or specified by entering a specific value. The Loop Cut and Slide tool has an icon in the toolbar, but I prefer to use the keyboard shortcut, the Control key plus the R key. The Loop Cut and Slide tool is used in edit mode. After selecting the keyboard shortcut, the Control key plus the R key, You hover the mouse cursor over the mesh and close to one edge. Depending on the position of the cursor, a yellow horizontal or vertical line will appear. The leftmost button will add the loop of edges. Dragging will move the edges along the faces. The loop is fixed in place by selecting the leftmost button or the Enter key. Using the rightmost button cancels the action. Using the leftmost button anywhere in the 3D editor window other than on a mesh deselects the edge loop. The loop can be reselected by using Shift plus the Alt key. You can easily add more than one loop. After selecting Ctrl plus the R key and adding a loop, you can use the scroll wheel to increase the number of loops. You can also use the number pad key to change the number of loops. After being fixed in place, the loop can still be moved by selecting a loop with the keyboard shortcut, the Shift key plus the Alt key, then using the keyboard shortcut, the G key, followed by the G key, and dragging. The loop can also be moved outside the confines of the mesh, a form of extrusion. Use the keyboard shortcut, the C key, and drag the loop. The Subdivide tool is found in the Edge menu. In Edit mode and Edge Selection mode, after selecting an edge, select the Edge menu and Subdivide. In the option window that appears in the bottom left-hand corner, you can increase the number of cuts. You can subdivide between two edges. Select the two edges using the leftmost button, then Shift plus the leftmost button. Then select the Edge menu and subdivide. The face is cut in half. The same result could have been achieved by first subdividing each edge individually. And then switching to vertex selection mode and connecting the two new vertices using the keyboard shortcut, the J key. Again, the face is cut in half. However, by connecting the new vertices using the keyboard shortcut, the F key, the face is not cut in half. There are two ways to extend an edge. If the edge is aligned with one of the axes, you can select one of the end vertices and use the Extrude tool to extrude it further along the axis. For example, if you select one of the vertices of the cube and then select the Extrude keyboard shortcut, the E key, then constrain the extrusion to the y-axis by selecting the keyboard shortcut, the Y key, and then drag the vertex, you can extend the edge along the y-axis. However, if the cube is rotated so that the edges are no longer lined up with the axes, this will not work. In this case, you can use the capabilities of the Edit Mesh Tools add-on that comes with Blender. This add-on may not be activated, but that is easy to fix by going to the Preferences window, selecting the Add-ons tab, typing in Edit to locate the Edit Mesh Tools add-on, and checking the activation box. Be sure to save the changes you have made to the preferences before closing the Preferences window. Now all you have to do is, in Edge Selection mode, select an edge, right mouse button to bring up a pop-up window, select Edge Tools, and select Extend. In the option window that appears in the lower left-hand corner, you can select to extend the edge either forward, backward, or both. You can also extend the end vertex of an edge by selecting it, then selecting the keyboard shortcut, the G key followed by the G key, and dragging the vertex into the edge. Then selecting the keyboard shortcut, the C key, and dragging the vertex beyond the confines of the edge. The TinyCAD Mesh tool is an add-on that originally you had to buy, but it is so useful, Blender now includes it with the program. But to use it, you may first have to go to the Preferences window, select the Add-on tab, search for Tiny, and check the activation button. The add-on appears in the 3D Editor window at the top of the pop-up window that appears when you use your right mouse button. It has several options, but I use just the one at the top of the submenu, the VTX AUTO. This option splits two intersecting edges. Here we have two intersecting edges. By selecting them and then VTX Auto, we can split them at the point of intersection. The Inset tool insets a face. In Edit mode and Face Selection mode, after selecting the face to be inset, you select the Inset keyboard shortcut, the I key, and drag. Note that the farther away your mouse cursor is from the mesh, the greater control you have over the action. You can also increase the control by holding down the Shift key. This applies to many actions, not just Inset. From the option window in the lower left-hand corner, you can control the thickness of the inset and the depth. The Bevel tool takes a selected edge and rounds it off. With the Bevel tool, you can bevel a selected edge or edges without affecting the other edges of the mesh. In Edit mode and Edge Selection mode, you can select the Bevel tool from the toolbar. Select the edge to be beveled, then drag the yellow guide. In the option window that appears in the lower left-hand corner, you can select the number of segments, the width of the bevel, and even whether the bevel affects the edge or the end vertices. If you select a face in Face Selection mode, all the edges of the face will be beveled. The Bevel tool is often used to make edges look more realistic. Edges usually are not sharp, but worn in some way, and the Bevel tool can create that wear. The Knife tool allows you to add vertices, effectively cutting the edges that you cross over. The Knife tool can be used either in Vertex, Edge, or Face Selection mode. After selecting the Knife tool from the toolbar, you can start the cut outside the mesh using the left mouse button. Then drag the mouse cursor over the mesh where you want the cuts to occur. Red squares appear where the new vertices will be placed. To confirm the cuts, select the Enter key or the space bar. You can also start a cut on an edge and end on an edge. You can start a cut in the middle of a face and cut out a hole. The Knife Project tool uses a cutter template to precisely cut a shape into a face. Let's demonstrate using a circle as the template and a plane as the target surface to be cut. In Object mode, I'll add a plane by using the keyboard shortcut Shift and the A key to bring up the Add menu. Then select Mesh and Plane. To add the circle, again I'll use the keyboard shortcut Shift plus the A key to bring up the Add menu, then select Mesh and Circle. To fill the circle, in the option window in the lower left-hand corner, under the Fill type, I'll select Triangle Fan. I need to have the cutter circle a bit above the target plane, so with the cutter circle still selected, I'll use the Move keyboard shortcut, the G key, and drag it up on the Z axis. I also need to be viewing the plane face on, so I'll select the keyboard shortcut, Numpad 7 key, to switch to top view. I think I'd like to scale down the circle a bit, so I'll select the Scale keyboard shortcut, the S key, and drag. By positioning the mouse cursor away from the mesh, I can better control the scaling. To create the cut, I'll make sure that I am in object mode. Then, in the outline window, I'll select the target, the plane. Then I'll switch to edit mode. And in the outline window, I'll use the keyboard shortcut Command plus left mouse button to select the cutter, the circle. To make the cut, I'll now select the Mesh menu, then Knife Project. In the outline window, I'll hide the circle by selecting the eye icon. And with the mouse cursor hovered over the 3D editor window, I'll delete the still selected circle cutout by using the keyboard shortcut, the X key, followed by the F key. This sequence of action is important for achieving a knife project. View the surface to be cut face on. In object mode, select the target. Switch to edit mode and select the cutter. Select the Mesh menu and Knife Project. The Snap tool is used to precisely align vertices, edges, and faces. The Snap tool is found in the 3D Editor window menu bar, represented by a magnet icon. To the right of the magnet icon is a drop-down menu of elements that you can choose as the target of the snap. By default, it is set to increment. If you select the cube and drag it along one of the axes, for example, using the keyboard shortcut G key followed by Y key, it will snap incrementally to the grid of the 3D Editor window. Usually, you will use vertex as the target. For example, in edit mode and vertex selection mode, if you select a vertex and extrude, keyboard shortcut E key and drag, when you pass the mouse cursor over another vertex, the end of the edge will snap to that vertex. The snapping is indicated by the target vertex taking on a yellow circle that disappears when you use the left mouse button to complete the action. The two vertices are merged, but the face is not subdivided. You can snap using an edge as the target, or you can snap using a face as the target. Snapping to the 3D cursor snaps a mesh using the mesh's origin. The origin of a mesh is indicated by a yellow dot. Here the cube's origin is at the center of its geometry, and both the cube's origin and the 3D cursor, represented by a red and white circle, are at the scene origin, x equals 0, y equals 0, and z equals 0. The scene origin is also known as the world origin. Let's move the cube away from the scene origin. In object mode, I'll move it along the y-axis. Keyboard shortcut G key, followed by Y key and drag. Now with the cube selected, I can move it back to the 3D cursor by bringing up a pie menu, keyboard shortcut Shift key plus S key, and selecting Selection to Cursor. The origin of the cube is snapped to the position of the 3D cursor. You can use snapping to 3D cursor to move a vertex, edge, or face of a mesh to the position of the 3D cursor by first setting the origin of the mesh to the selected vertex, edge, or face, then moving the mesh to the 3D cursor. For example, let's again move the cube away from the 3D cursor. In object mode, I'll again move it along the y-axis. Keyboard shortcut G key, followed by Y key, and drag. This time, I'll switch to Edit mode and Vertex Selection mode, and select a corner vertex. Now I'll move the 3D cursor to the vertex with the keyboard shortcut Shift key plus S key, followed by Cursor to Selected. Then I'll switch back to Object mode, and with the mesh selected, move the origin of the mesh to the 3D cursor by selecting Object menu, Set Origin, and Origin to Cursor. Now I'll move the 3D cursor back to the origin of the scene with the keyboard shortcut Shift key plus S key, followed by selecting Cursor to World Origin. I can now move the selected vertex along with the mesh to the 3D cursor by selecting Shift key plus S key and Selected to Cursor. The vertex to which the origin of the mesh has been positioned aligns with the 3D cursor. Note that this last move must be done in object mode. If in edit mode and vertex selection mode, you attempt to move the mesh to the 3D cursor with Shift plus the S key and Selected to Cursor, you will instead collapse all of the vertices onto the origin of geometry of the mesh. A mesh can be hidden in its entirety by selecting the eye icon in the outline window. In edit mode, individual vertices, edges, or faces can be hidden by selecting them and then selecting the keyboard shortcut, the H key. For example, selecting a face of the cube and selecting the keyboard shortcut, the H key, hides the face. Selecting the keyboard shortcut Alt plus the H key unhides what is hidden. Selecting a face of the cube and selecting the keyboard shortcut Shift plus the H key hides all of the mesh except the selected face. Faces have two surfaces, an outside and an inside. When it comes to texturing a model, the texture will only appear on the outside, much like a t-shirt with a logo on the outside, but not on the inside. One way to tell which is the outside and which is the inside is to select the overlay chevron and then select the normal face icon. Blue lines appear perpendicular to the outside surface of faces. The length of these lines may need to be increased to see them. Another way to tell which is the outside and which is the inside is to select the overlay chevron and then check the face orientation box. The outside surfaces of faces are represented in blue, and the inside surfaces of faces are represented in red. For example, if you hide one of the faces of the cube by selecting the keyboard shortcut, the H key, you can see the red inside surfaces of the faces. The red surfaces also do not have blue lines extending along the normals. A face can be changed from inside to outside by selecting the Mesh menu, then Normals, then Flip. You can also select all of the faces with the keyboard shortcut, the A key, and then select the Mesh menu, then Normals, then Recalculate Outside. The Transformation Orientation tool is located in the 3D Editor Window's menu bar. In Object Mode, if you select the Move tool from the toolbar and then select the cube, you will see that the Move gizmo is aligned with the X, Y, and Z axes. Dragging one of the handles will move the cube along an axis. Even if you rotate the cube, say around the X-axis, by selecting the cube and selecting the R key and the X key and dragging, the orientation of the Move gizmo does not change. If you drag one of the handles, the cube still moves along the X, Y, or Z axis. This is because you are in global transformation mode. You can change the transformation orientation. The other useful option is local transformation mode. Now when you select one of the handles, the cube moves perpendicular to the cube's faces. Changing the transformation orientation also affects other transformations, that is, rotation and scaling. In Object Mode, under the Object menu, there is a selection for Shade Smooth that allows you to apply a computer routine to smooth the surface of a mesh. For example, to smooth a beveled cube, in Object Mode, select the cube, then select Object menu and Shade Smooth. Built-in computer routines make it easy to apply effects that would be difficult to achieve manually. Selecting the Object menu, then Shade Flat, removes the smoothing effect.